Today's Wednesday.
Chairman of our board.
Today's Wednesday. It's 4:30. This is the Water Quality Management Committee. Hopefully you're all in the right location. We go for 2 hours. Those who have attended in the past know that we get out of here by 6:30. Irregardless if we get through the entire agenda or not. I notice a number of people who have not been here before. So just a little ground rule: if you're going to speak or talk, you have to get to one of the microphones because we are taping this, and you have to identify yourself the same as in any other public forum. We're going to start tonight with item 1, which is a discussion or a presentation from John Ramsey, who's from Sustainable Coastal Solutions. John has been a consultant to the DPW relative to the inlet widening and the replacement of the bridge at Florence Pond. We invited John to come in and explain a little bit of where he's at or what he's been looking at, because a couple members of this board a month and a half or so ago wanted to ask a couple of questions. Since then, I think we've educated ourselves a little bit that A, the bridge is in really bad shape, so it's got to be replaced no matter what. And it's a DPW project at this point. It's not necessarily a project of this group, but this is a reasonable forum to collect information, find out a little bit more about how we got to where we got to.
Sure. And I was, so again, I'm John Ramsey from Coastal Solutions. So I just wanted to go through a little bit of background on how we got here. But one of the things I was asked to by Peter McConnery at DPW was to actually talk a little bit about some of the more recent data that we've had as far as total nitrogen information. Yep. And kind of see how that looks relative to what we based all of our design stuff on in the first place. Yep. So
could you give a little setup? Some people may know that the permitting's taken a long time,
sure.
And so we got into a second round of.
Yeah, so I maybe just giving you guys a quick assessment of permitting. So, we started permitting this many years ago, probably around 2014, I believe. We started permitting this whole process. At the time, the bridge process went, I will say, did not go all that smoothly. We did have some issues with some neighbors that appealed the project, and it kind of dragged things out. We eventually got the bridge permitted, but by then, the bridge, the beach on the west side had been eroding pretty significantly. And so the town had decided to make sure they wrapped the two projects into one. And believe it or not, it took us 4.5 years to get our Army Corps permit for that portion of the project. So we finally just got all of our permits last summer. So we're putting together the bid package to go out, and now I believe it's in Mass DOT's hands to try to get that bridge. I know how that goes. We're trying to get the whole bridge, the whole package put together as one project so it can be all done at once. And people should realize that when this project is done that it's going to be likely close the roadway there across the bridge for 2 years. So it would be started in the fall, and then it would be closed for 2 full years in order to get the bridge replaced. It's a significant project, and with widening the inlet and rebuilding the jetties, and also building groins and a beach nourishment project on the east side to make sure we can maintain the road. That's really what the project's about. But I would point out that obviously the road's very low. As you've mentioned, the bridge is not in the greatest of shape. As you drive up to the bridge, you can see that the area on both ends of the bridge have settled pretty significantly. And so, obviously to bring that back up to where it needs to be. People had asked, again, I don't want to go into all these things in great detail. People always ask, sea level rise, should we elevate the road? It was the town's decision at the time to not elevate the road, to make sure people with boats would not start getting up into the pond, et cetera, and keep the pond the way it was. So that was the decision that was made. So, whether there might be a way of getting a little bit of elevation in the roadway, but for the most part, the bridge is going to be at the elevation we see. So just to give you, this is actually Bournes Pond Inlet. I know it looks just like a nice picture on the coast and a wavy day, but that's actually during Hurricane Sandy back in 2012. So kind of when we started all this process of the permitting. So first off, I'm also, besides doing the work relative to a lot of the permitting and engineering design for this. I was also involved with the Massachusetts Estuaries Project originally. We did the work with SMAS to do all the modeling for the system, and this is just the model grid for Bourne's Pond. I believe that was done around 2006, 2007, so that's been around quite some time. But this was the basis for a lot of the modeling that we did going through this system. And, again, that's just showing the bathymetry, the water depth, so you can see the water depth is deeper offshore, and the going up to the red colors where it's the shallowest. But again, this is a very shallow system, but it also has a very small tide range as well. So as part of the design project that we did, we actually went out and collected new bathymetry, got in there, did more detailed work so that we could have a really defined process for widening the inlet and coming up with exactly what the impacts of widening the inlet would be. This is, again, existing bathymetry. You see if you go out there, you see that shoal that's offshore that's shown there in yellow. It's a pretty consistent ebb shoal that sets up. The town dredges through it on occasion to reopen the inlet. On the inside, you see that very deep scour hole shown in the blue, just north of the bridge. People seem to think that is the best fishing hole going. So, I mean, if you want to catch some nice straight bass, it's a great place to go, and actually fluke as well. So, but again, we did some of this just to make sure we had a good updated model for looking at various alternatives. And this is just the updated model grid that we use to evaluate the work to make sure that we were evaluating the tidal currents and water quality properly. This is just a quick synopsis showing the widened inlet version. The inlet is going to be widened to almost 100 feet. And what we were looking at is for the max flood currents and max ebb currents, and I'll show this in a minute. One of the things we want to make sure is that the inlet itself can maintain itself without having to be dredged. The inlet, obviously inside and outside may have to be dredged occasionally, but we want to make sure the inlet itself didn't need to be dredged. And the way you set that up is you want to make sure that sand is mobilized and moves through. So typically what you do is you try to make sure that at some point during the tidal cycle that you're getting currents on the order of 3 feet per second or greater to make sure that the sand keeps moving along. So that's kind of a limitation. So the concept, some people think you just widen the inlet to the maximum thing that you can, which is kind of a great idea in the perfect world. But if you did that, what it ends up doing is shoaling in. So there's kind of a limitation to how wide you would want to build your inlet. And this kind of goes to, if you look at Great Pond and Green Pond, those inlets are actually wider than they need to be, hence why you have to actually dredge in the inlet occasionally just to keep them open, because the inlet actually wants to shoal itself in. So this is just some model results, and again, I don't want to go into it in too much detail other than if you look at those dashed lines, those are those magic 3 feet per second lines. And so if you look at existing conditions, that's the highest and lowest curve, the most excursion you get. And during some of these tides, we actually get in the existing inlet about 6 feet per second. I mean, if you go down there, the tide is screaming through the inlet. It's stronger during the flood, a little bit weaker during the ebb. But if we widen the inlet, we can run those scenarios in the model and come up with the different peak flows. And what you see is this is kind of going through all that series, the series of different inlet widths we did, existing 75 foot, 100 foot, 125 foot, just to get an idea of what the various scenarios would be. And this is kind of putting it on one plot where you have the top, the blue is the flood tide velocities, the bottom is the ebb tide velocities, and on the x-axis there is the inlet width. So you see as we widen the inlet, the peak velocities get lower and lower. And then we have that sweet spot right around 3 feet per second, and you see that's pretty close to the inlet width of 100 feet. So at around 100 feet, we get to that spot where we can basically make sure that the inlet will maintain itself. So that's where we targeted the inlet width, and then we went to the standpoint of, well, how much would this improve water quality? And so this is the results of the water quality model. It looks very subtle here, but I'll talk about the numbers in a minute. On the left is existing conditions. On the right is with the inlet widened. The colors don't do it justice. The lines do better, but you do get quite a bit of shift in the lower part of the estuary of some pretty good water quality numbers moving much further north. Obviously, the north part of the pond stays very high nitrogen. It does not flush nearly as well, so the effect of widening the inlet does not really reach all the way up there, but it reaches part way up.
Can I ask, what are we looking at with
And I'm going to talk about that just a second here.
Okay, thank you.
So, and just to point out what the difference is, so this is with the inlet improved, and so what we were focused on is the station in the middle of the estuary, which is the Sentinel station for the Estuaries project, that station B3, which is, do I have that pointer? Push up, okay, so it's right up here in the middle. So that is where we're targeting the water quality improvements to see what we do, and we're getting about an 8% improvement in the total nitrogen concentrations. And if you go further south, you're getting up to around 15% improvement as you go down the estuary. So even though it shows very subtle, it is a marked difference. And one thing that is important to think about that, it may seem like it's not much, but what that equates to is would be the equivalent of a 57% reduction in the total nitrogen load to the watershed that's right directly adjacent to Bourne's Pond. Not the river, but the watershed that's adjacent to the pond. So this would basically be equivalent of sewering 57% of the houses in that watershed. So that was the sort of the basis for why we came up with this, why we're widening the inlet. From a cost-benefit standpoint, that seemed to work out. The numbers were done as far as what the cost-benefit was. I did not bring that, but that is the basis for it, that doing this inlet widening is much cheaper than that. And the other thing to point out, the one thing I think is important for the town and for everybody else here, is when you do an inlet widening, that improvement is immediate. You don't have to wait when you do the sewering, it takes time for that water to, the water that had already been in the groundwater to seep into the estuary. This is an immediate effect. So as soon as you widen that inlet, you get this effect instantly, this reduction in nitrogen. And I know there's probably going to be questions on what I just presented, but I did want to kind of sort of run through this data, because one of the things I was asked to look at is some of the other data sets that exist, and why, how does this compare to what we had in the first place, the assumptions we had. So we looked at, both the Center for Coastal Studies stations. Those are generally further offshore, but they also have one in Bourne's Pond. I put these as Vineyard Sound, Nantucket Sound, and then there's one that's off Pompanesett Bay. And then the blue dots are that B3 and the VS station, which is the Vineyard Sound station that the Pond Watch group has been monitoring over the years. And just a quick look at the offshore stations that the Center for Coastal Studies have been monitoring. This is data from 2011 to 2023. I will point out that the center sometimes collects samples outside of the summer. So we tried to exclude those, because everything that we're doing, all the analysis that we've done is based on summertime only. So the gray bands you see there are the various summers through those years of the monitoring, and it just shows you basically the data. But what it really comes down to, the offshore data, and this is again far offshore, according to them, the total nitrogen concentrations are about 0.16 milligrams per liter, which is very low. It's basically like the Atlantic Ocean. Not really surprising. And then if we look at that station offshore Pompanesett Bay, and then also the one in Bourne's Pond, you get a little bit different numbers, but the one off of Pompanesett Bay is actually still, the mean is around 0.16 milligrams per liter. Again, it's not right off the mouth, it's kind of far offshore. But then in Bourne's Pond, the TN is about 0.57 milligrams per liter, which is pretty much what we monitored back in the early 2000s for that station B3. So that's pretty much exactly what we expect it to be. Going to the Pond Watch data, this is a little trickier to analyze, and I would encourage the town, Amy, poor soul, to maybe do a little bit more in-depth analysis on this. I just got this data the other day, and we started looking at it. And one of the things that pointed out to us is some of the surface samples have some very high kind of outlier numbers. You look at some of the ammonia or salinity, you realize there's some stratification. And so the one thing I'd like to point out about this station, it's in Vineyard Sound, but it's immediately off the entrance of Bourne's Pond. So when you're on a calm day and you're on an outgoing tide, when these samples are done, chances are you're catching quite a bit of the water that's coming out. So a better way to probably look at some of this information is to look at the non-surface part. Not the non-surface, you've got two samples below that, the 1 meter and 2 meter samples. And it would be better just to focus on those rather than the surface samples, because they do have tendency to have quite a few outlier data points. And so I looked at all of the data, and we're getting somewhere around 0.34 milligrams per liter offshore. But if I get rid of the 2 standard deviations away, it only drops down to about 0.34 offshore. But I'll talk a little bit more about this in the estuary. But again, we were using between 0.28 and 0.30 for our boundary condition when we were doing the estuaries project. This is about 0.33 milligrams per liter, so they're pretty close to the same. So we, again, far offshore you get 0.16, close to the estuary we're getting somewhere in the low 0.3-ish, and because we know there's some intermixing, and when the estuary flushes out, it does return some of the water. On a windy day it returns less, but on a calm day it returns more. So overall, it's not bad to use the average here to look at, and so that matches really well with what we used as an offshore boundary condition. And then going forward to Bourne's Pond, kind of a similar problem, and I don't know why this is, but again, I think there might be some surface algae blooms, and we have, if you look at some of this data, we actually have surface samples that show, and I know, I talked to the people at SMAST, they're confident that the data is correct. They went through it with a fine-tooth comb, but when you have a 3 milligrams per liter TN concentration, that really does throw off your mean. That's obviously some sort of algal bloom that's going on at that time, and even the stuff it's up around 2 is kind of questionable. So I mean, generally in the system, we'd see surface samples that are closer down to 1 or below. When we were doing our sampling, we found, again, if I look at the Center for Coastal Studies, they're getting 0.57 milligrams per liter. If we go and get rid of the surface samples and actually do the same thing, just to be consistent and get rid of things that are more than 2 standard deviations above the mean, we're actually getting 0.61 milligrams per liter. So again, this data is really coalescing right around the same thing that the Estuaries Project used and what's being shown by the Center for Coastal Studies. So I'm confident that the data really hasn't changed, and the effect of this inlet widening is going to be what we expected it to be. Just kind of summarizing that, we had the original MEP analysis, which was data that I believe went through the 1990s up to around 2006. Then we have the Center for Coastal Studies data 2011 to 2023, and then Falmouth Pond Watch 2016 to 2023. And if you look at the table, Vineyard Sound, the MEP was 0.28 to 0.3. The Falmouth Pond Watch is 0.33. The further offshore station at Coastal Studies was much lower. I'm not saying to use that. That would be, that would make the improvement drastically higher, which would be great, but it's not probably a valid number to use. But I think the numbers that we're using are within the range of what we expect. And then Bourne's Pond, just to see how Bourne's Pond is it getting a lot worse, or is it staying the same, or is it getting better? Again, it seems to be spot on. The MEP analysis 0.58, Coastal Studies 0.57, the Falmouth Pond Watch, the newer data 2016 to 23 is, if you get rid of the outliers, which we would have gone and done an outlier analysis to do the original stuff anyways, is coming up 0.61, so it's pretty consistent. So that's sort of where we're at, and I just wanted to certainly answer any questions you guys might have. I just didn't want to. I know you only have 2 hours, so I don't want to do it. No. There's more people here than usual, so I just wanted to let them know sort of the format we had at the beginning. I typically allow board members to ask questions first and then turn to the audience. Everybody needs to, I think Tom had his hand up rather quickly.
One of the key things I think we're looking at is what changes there might be in our various embayments over time. And this indicates remarkable, almost kind of crazy consistency in Bourne's Pond over the length of time that these samples have been taken, right? Because you mentioned that one set of samples was really the last few years. I forget the timing.
Yeah, so I mean, so you have 2016 to 2023 is the Pond Watch data that we just, Kristen just sent me.
And the MEP data is back to 06 or something?
It's 1992 to, I believe when the report came out, 2006, might be 2005.
Right.
But
so
it's,
to me, this is almost scary, given what we think is going on in our embayments. I just wanted to make that point here to the group, that this is remarkably consistent over time.
Yeah, and I think obviously you guys have other estuaries. It sort of depends on how much development's been done in the estuary. I'm sure there's been some development in this watershed, but it's certainly not one of the more aggressively developed areas. So that may be some of the reason. I think the town has also done in recent years, I think they've done a better job of keeping the entrance open.
Yes.
Because when it shoals, obviously it flushes more poorly, and so it's not surprising. I think that'd be one thing to make sure that the town has the funds to make sure they maintain this until we get this constructed.
Go ahead, Steve.
Can you go back to the last map you had up there?
Now you're quizzing me here. That one?
No, before that, sorry. Yes. Where is the northernmost sentinel station?
The northernmost station, so our sentinel station for this estuary is here. The northernmost station is almost all the way up at the north end.
And if you do, I'm approaching the effect maybe a slightly different way. If you did the inlet widening, there would be some improvement in the nitrogen concentration at the sentinel station, just from that alone.
Correct. And most of the improvement would be south of there.
Right.
To be fair.
Right. If you then went and did the necessary sewering and perhaps IAs north of there to bring the northern part of the estuary up to standards,
Mm-hmm.
then now go back and pretend you did that first
Okay.
before you did the inlet widening, because you know you're going to have to do it anyway, in theory.
Right, and I think one of the things that we did for this, and I don't have the graphic, but so in order to come up with how many that 57% number of how many houses this would eliminate, we actually did a model run where we were removing things from the watershed until we got there. So we sort of did a scenario like that, and what that does is it tends to improve the estuary, further north, the estuary gets improved more so than maybe down at the south end. So the inlet stuff really does a great job at the south end, but maybe doesn't reach all the way up as far north as you go. But if you did the north stuff first, that would just increase the improvement of this.
This is just a thought experiment. I'm not
Yep.
actually proposing any order of doing things. But I'm saying, since you know you're going to have to do this upper work anyway, imagine doing that first. Enough of it to bring down to improve the northern part of the estuary
Mm-hmm.
sufficiently to be acceptable. Now, having done that, now we bring in the inlet widening as the marginal condition instead of the other way around. How much of an improvement does it make, since you've already done this huge improvement that you know you're going to have to do anyway?
I mean, if you did all that, you would probably have over-sewered or over-removed nitrogen, because you would actually bring it back to beyond what you needed to. The other thing I would point out is way up in this northern part, no matter what you do, it's just the natural part of the system. That is going to be a very difficult area to get, it's never going to achieve what's down in the middle, even if you remove pretty much everything. Just people's lawn fertilizer is going to keep the nitrogen way up the northern end relatively high. It's just a natural condition.
But I'm saying, if you have to do that anyway, and it's got to be substantial to fix the upper estuary, then maybe the lower estuary is perfectly fine without any inlet widening.
Oh yeah, definitely. And there are sewering solutions or wastewater removal solutions that you can do for this estuary and not widen it and achieve your target. So
But I'm saying ones that you're going to have to do anyway, even if you do the inlet widening.
there are going to be some, yeah. I mean, so
I'm going to try to walk them through this a little bit if I can.
Yeah.
So what you're saying is if you take care of the upper portion of the inlet, doesn't it make the lower end good again? What you're leaving out is the fact that those 57 homes are still contributing nitrogen to the lower end because they're not sewered.
Right, but
Okay,
if the level is acceptable,
No,
it doesn't matter.
It won't. The original model work and everything points out that you still have nitrogen coming to the lower end. You're still gonna knock more nitrogen down.
Yeah, so, I mean, we did do a series of
But not as
alternative.
much.
Not as much. I mean, the inlet takes care of a certain, I mean, think of it this way, the inlet takes care of a certain percentage of
You'd have to
source.
sewer those 57 homes, and that's a bit greater cost than the inlet widening.
Okay, I won't waste any more time.
Can I make a quick spin on this while we're on this topic? Is this presentation makes us think of the quality improvement in a planar sense and what we need to think of in a volumetric sense, because the lower part of Bourne's Pond is probably 80% of the volume of water that's in that embayment. I don't know the numbers, John, you probably know them, but the point is if we looked at volumetric improvement as a percent of the total, you'd see that, I'm guessing, because I haven't run the numbers, but I'm guessing that you would see that this is a really big deal, because it's such a tremendous volume of water relative to the entire embayment that's being improved.
And I would point out that, I mean, you know, part of this, from the Estuaries Project standpoint, we always had the sentinel stations we were looking at. And in this case, B3, that one halfway up, is the sentinel station. And so we're trying to, the idea was to improve that. And I believe in this case, at some point, you know, the eelgrass would be halfway up to that. Just because the natural embayments here, before there was development, you know, some data indicates that in the lower basins there was eelgrass. But the expectation that you would get eelgrass all the way up to the upper end is just not something that would never, ever have naturally existed there. So, you know, so we targeted this to kind of go back to be close to the healthy sense of the system. So again, we're not, I don't think there was any effort to look at, you know, how much improvement we're going to get at those two northern stations, but it is the understanding if we improve at the that mid station to the level that would be very healthy, that the upper portion would be at least its natural nitrogen concentration up there that would be more similar to what it was before we did a lot of development.
Other board members, comments, questions?
The number, I'm having a little trouble understanding how you got to a 50% reduction, excuse me, in total nitrogen, 2,000 kilograms a year, which represents approximately 40% of the TMDL number we've got to get to as a town.
Yep.
But from the percent changes, you know, you must, how did you come up with 2,000 kilograms?
So what we ended up doing, so as I said, we did two model runs. We did this model run with the inlet widening, and then we did a separate model run where we kept lowering the wastewater loading coming in until we came up with an equivalent percentage increase. This kind of basically the same table. And then you do the comparison, and then you figure out how much nitrogen you ended up removing in order to achieve the same concentrations of nitrogen.
Okay, so you were kind of working backwards to how many pounds or kilograms you would have to remove
In order to get this scenario.
get to that concentration, and that backed into the 2,000. I mean, it's an impressive number when you think, wow, that's 40% of the reduction we need to hit TMDL.
And it is,
Okay.
I mean, yeah, and this is, and I will say, this is probably one of three systems in all of the Estuaries project where it is worth widening an inlet. There are very few of these.
This
It's
was
just,
the fundamental conclusion a long time ago that Bourne's Pond widening had a real impact.
yeah.
Okay?
And so this is a very unique, I will say it's a very unique situation. And it took, and a lot of the permitting stuff took a long time because it required, in general, DEP does not like to permit something, some sort of coastal engineering structure type thing to improve water quality. It is very outside their comfort
We're all
zone.
fans of the DEP in this room.
So it took a lot of people. I will say it took a village, believe me or not. Yeah, I mean, Virginia and everybody else was certainly involved with this heavily. Eric Turkington, we all went up to these meetings, and it was a pretty hefty fight to get where we got.
Okay, I'm going to let the audience, if they have questions, I ask you to stay on topic to, you know, why is the inlet being widened as much as it is, and the benefit of it. Our esteemed selectman.
Hi, Doug Brown, Select Board. John, did I hear you right, that there's an opportunity still to elevate the bridge a little bit?
You'd have to, I think from this standpoint, I think there might be an opportunity to elevate the road a little bit, but I think the bridge is probably set at this point. It's already up at Mass DOT for plans. But and that's a process in itself. So if you want to talk about that, you may want to just reach out to the DPW director and see. I mean, I think there's a lot of pressure to get this done.
I'm going to do this. The design is done.
I have been resigned to the fact that.
And so what, if you want to go talk to the DPW about raising the thing up a bit, we're probably going to delay the project further because we'll have to go back to redesign.
Never mind.
And right, and the one thing I would like to point out.
I mean, that's where we're at. I mean, the
Right.
plans are done.
Yeah. Okay.
And the one thing I would like to point out, the bridge is low, that whole area goes under during a major storm anyways. But the one thing I will point out is part of this project is to widen the beach on the east side and to give that a better buffer than it has now. And then also to restore some of the dunes on the west side. So it is going to have a resiliency component to it. It's just not going to be resilient enough so that it is, going to, deal with a major storm. But I think where you go from Surf Drive all the way down here, there's the roads are just not high enough to deal with that issue directly. I think that's just something we're going to have to deal with. Getting comfortable, it's going to flood on occasion.
They're not high enough now.
They're not high enough now, and there's no way to elevate them enough to get them out of the floodplain.
Okay, thank you.
Yeah.
Just come to the microphone, identify yourself. Yep.
My name's Ann Pride. I live right here. Okay? That's 94 Bournes Pond Road. In general, I don't support widening. I think Mr. Layton was headed towards a point I wanted to bring up, which is that what is the total cost for IA systems for these homes? I'm still unsure about total homes impacted north and south. I know there are 47, I guess, down in my area south. What is the cost of an IA system multiplied by the number of homes? What does this project cost? Mr. Rafferty, you kindly suggested I contact Jim McLaughlin at the end of the last meeting, asking for the current budget, which I know is not going to be what the budget is, but the latest budget. Multiple calls, emails, I never received it. What is the cost of this? And if we are going to do this, it should certainly be elevated. Come on. It gets washed out sometimes. You know what's happening. You know what can happen. We should not be building a new structure like this without considering elevating it. But again, I'm opposed to widening. I think we should just replace the bridge that we have now, look at the cost, at least examine the cost for IA systems versus what this is going to cost. Nobody has any idea. We were at 11, I bet we're up to 15 or more $1 million for this thing. 2 years of, and believe me, our neighbors are going to be happy not to have Central Ave, the runway, and operational for 2 years. But 2 years, probably 3 years. I mean, let's be reasonable. And coastal erosion problems and commitment of the town to dredge when necessary, these are all concerns that I have. Thank you.
I will reach out and see if I can get you the current cost estimate.
Thank you.
Hi, my name is Lee Dakota, and I want to thank you all for your concern and all the hard work that you do. I am a member of the family that John was talking about. So we have 2 homes. One is the property right here on the beach, and the other is the one right there on the small round pond. And our concern was what the erosion impact will be on our properties. Of course, we care about water quality, but we also care about erosion for our properties. We were promised that there would be dredging through the process that we went through several years ago, that there would be dredging because if this shoals up, which we see it does constantly, this isn't going to be effective. So nothing has been dredged for several years now. I don't know how they would dredge the interior of Bournes Pond. I understand how they can dredge the exterior.
I think the plan is to remove the bridge, dredge the interior.
Every 2 years is what we were told. It would be dredged every 2 years. So I don't think they're removing any bridge every 2 years.
John's going to clarify that a little bit. But my understanding of the sequence on the project is the bridge is coming out. Then they're gonna go into the pond and dredge the inside of the pond, because they can't get the dredge inside there right now. And then they're gonna put the new bridge back in, which has got the higher velocity to help keep it open. That sand's being relocated to the east to build up in front of your area. That's what I understand.
So I just want to point this out, and I mean no disrespect to you and what you do. We have been very fortunate to be able to use seawalls to protect our property, but I will say that you don't truly know the impact on land and on water when you change something. You don't truly know it. We've seen it in our property. So I think to say, oh, it won't shoal in anymore, I think that's not necessarily what we're going to say. So I understand your priorities, and I respect that. I respect his expertise. I think what Mr. Layton is suggesting is very valuable and worth considering, that we reverse this process. And I would just like to say, on behalf of my family and those two properties, we are not for widening the inlet. Thank you for your time.
Okay, thank you.
I can at least try to answer at least a bit of the questions about dredging. So you're correct, when we take the bridge out, that's when we would develop the full wide channel going back. There was a time, and you may remember, and it's been several years, because the inside very rarely needs any dredging. There was basically they dragged a bucket up a drag line up into the system and actually were able to dredge without going under the bridge. So it can be done. We don't anticipate that the channel inside is going to need any more maintenance than it typically does. The outside shoals in pretty much a lot right now, and that does impact the flushing of the inlet. But at the same time, yes, the town's going to need to stay on top of it. This project actually gives the town the opportunity, because in the permits for the project, and it's specifically for the beach that's being done on the west side, they're required to maintain those structures to entrapment. So there's an impetus that the town is going to have to dredge in order to basically put that material on those structures to make sure that they stay filled. So that is part of this process. It is anticipated, based on what the town had historically done, that every 2 years they would be dredging offshore, but it really is memorialized in this whole monitoring plan and stuff for the permit. So I think the way this project is being done, you're going to see more proactive maintenance on that inlet than you have historically. And that's because it's going to be required by the permits.
Additional comments? All right, thank you, John. Can you make sure that Kristen gets a copy of your slides?
I have it.
You got it? And then through, I guess, your office, Amy, we post it onto our webpage for people to be able to access it. At the start of this meeting, we actually have a sort of introductory slide that tells you when our next meetings are, what we think the topic's going to be, and also identifies the webpage you can go to or how you can get this information. Okay. With that, we're going to have our wastewater superintendent, Amy Lowell, make a presentation on the outfall and where we've gotten to and where we're going to go to.
Good evening. Yep, so today I was asked to do an update on Falmouth's outfall data collection and permitting. We've made a lot of progress since the November 2023 town meeting, when funds were appropriated for data collection and permitting. So first off, we've established a regulatory review team. The Department of Environmental Protection has taken a lead role in coordination of the permitting and environmental review so far, which has been very helpful. They've brought in folks who are relevant to each part of the permitting and environmental review process. We've been meeting twice monthly, most months, with the DEP and other regulatory agencies that will be issuing outfall permits. We've been meeting on specific issues with relevant agencies, including Coastal Zone Management, Division of Marine Fisheries, Environmental Protection Agency, U.S. Army Corps of Engineers, Department of Conservation and Recreation, the Water Management Agency, et cetera. we met with the Massachusetts Environmental Policy Act office to establish, to introduce them to the project and talk about the review process for the upcoming environmental impact report. So far we have very good regulatory engagement for this process. Also, we spent a lot of time in the first half of the year confirming with the regulatory agencies the scope of the environmental data collection that will be needed for the 2-year baseline survey that's required under the Ocean Sanctuaries Act. On the figure you see, the yellow rectangle is the area that we surveyed in 2022 to provide preliminary data for this project. Through the meetings at the beginning of this year, we ended up with a much larger survey area that's shown in the green outside rectangle. That larger eelgrass survey area is to allow the consultants to evaluate, and the regulators, to evaluate the existing and then in the future, the condition of the habitat along a gradient east and west of the proposed outfall. We've also, within that rectangle, you see a lot of circles with crosses through them. Those are approximate locations of benthic sampling as part of this baseline survey. There's a lot of data that will be collected from the benthic environment at each of those locations. So this, in combination, is a larger baseline survey effort. There is a funding request as part of one of the capital articles at this fall's town meeting for an additional sum of money to accomplish this greater surveying effort. We began, after resolving the process and the area of the survey, we began the 2-year baseline monitoring program in Nantucket Sound. The consultant performed 2 benthic surveys in 2024 and completed an eelgrass survey of that entire larger survey area shown on the previous slide in the fall of this year. After that survey was completed, we met with the Department of Environmental Protection and Coastal Zone Management Agency to review and compare that preliminary data, preliminary survey data, with the data that the DEP has collected, and really just to show them what we had preliminarily to date. And there was very good agreement. Oh, so the DEP on a regular basis does their own eelgrass survey along the coast, and they happened to update their survey most recently this summer. So we were able to compare those 2 surveys, and there was very good agreement between the DEP survey and the town survey, but it was also clear that the town survey provided a lot more data. The DEP survey is based initially on an aerial photography, and then they send divers in along transects to confirm what they're looking at in the aerial photography. And the town survey is with a remotely operated vehicle, which is taking video and photography and side scan sonar, and an enormous amount of data is collected. So the DEP was glad to have the data, or very interested in the data, and is in fact likely to use the town's data to do its final eelgrass delineation along the south coast. We completed the first year of baseline water quality monitoring. We've been monitoring at 3 locations. The one that's labeled FOF1, I believe that's Falmouth outfall something or other. Outfall 1 is the approximate proposed outfall location. We also have a very close to shore or more inshore location, and the farther out from shore location, the Nantucket Sound sampling location, is a long-term sampling location. It's been monitored for a long time, but this summer there was more data collected at that location as part of this survey. So dissolved oxygen, temperature, salinity, pH, and water clarity data were collected at the surface and around 1 meter off the bottom at both of these 3 locations, twice monthly from mid-May through mid-September, before 9 a.m. in the morning, because dissolved oxygen in particular is light. It fluctuates based on light. The nutrients: orthophosphate, ammonium nitrate plus nitrite, total dissolved nitrogen, particulate organic nitrogen, chlorophyll A, and phaeophytin also looked at the surface and 1 meter off the bottom once monthly, May to October, in the last 3 hours of the ebb and the first 3 hours of flood. I don't yet have that data, but it has all been collected and will be available for the baseline survey.
Amy, just stay at that one last slide. So are these the ones where the Buzzards Bay Coalition has been working with us on?
Yes, they've collected the data because they're out. They collect data in not only Buzzards Bay, but also in Nantucket Sound anyway. So they added these couple of stations.
Some of the stuff, like the eelgrass survey, that's all on the town put together to do. Some of these monitoring stations we're using, there's more than one entity involved in helping us to get the information.
Yes, we have several consultants that are working with us to collect this data. So the next thing I wanted to review was that we received very positive initial results from the USGS, the United States Geological Survey, evaluation of the potential effect of the outfall on the aquifer. The USGS has done their done all of the modeling that was requested of them under the scope with the town, and they've looked at the effect on the aquifer of discharging 2 million gallons a day to an outfall instead of to land. The USGS has a very detailed, rigorous peer review process, so we don't have their report in hand at this point, and we're not going to have it until July of 2025. But they did review with us the preliminary results of that, showing changes in water level from moving that water from land to the ocean. And we met with we asked the Water Management Act personnel to meet with us and the USGS to look at this data as well. The Water Management Act personnel are the ones who regulate the town's drinking water supply. And their feedback on the results was that it was not a significant impact to the town's drinking water supply. Obviously, when we have the report in hand, we will be able to provide a much more detailed summary of that, but it was very good news from both the USGS and the Water Management Act personnel on that. We completed the permit application process for marine soil borings. The goal of marine soil borings is to characterize the subsurface soils offshore in order, and actually one location onshore, for design of the outfall. As you know, we're planning to do directional drilling starting from Kite Park in Falmouth Heights and drill approximately south, about 2,300 feet offshore. So we have one boring planned for Kite Park, on land in Kite Park, and 6 more offshore. The borings will be 6 inches in diameter, 100 feet deep, and we'll use a jack-up barge that looks approximately like the one in this photo to do that work offshore. It's estimated it'll take a month to complete the 6 offshore borings. There is some potential for noise during the drilling operation. And the borings will be conducted this winter, assuming, which we do, that we receive the final permit from the Army Corps of Engineers to do this work this month. We're planning to start as soon as possible, and we expect the permit from the Army Corps of Engineers with this month. So we definitely want to get this information this winter so that we can use it for the preliminary design and have that available. This is a little obscure, but it's important as far as the permitting process. We confirmed that the Interbasin Transfer Act does not apply to Falmouth's outfall plan. The outfall infrastructure is fully within the town's limits. The seaward boundary of coastal towns in Massachusetts extends to the state's seaward limit, i.e. 3 nautical miles from shore. So discharging within that boundary means that our discharge is within the town limits. In addition, Falmouth does not plan to accept any wastewater from any other towns for discharge through the outfall. So those are the criteria for the Ocean Sanctuaries Act, that you're not discharging outside town limits and that you're not accepting wastewater from other towns. This would not have been a showstopper, but it would have resulted in another layer of permitting and state review. We've spent quite a bit of time in the last 6 months, or in the last 4 months, outlining the anti-degradation evaluation that will be required for issuance of an NPDES permit. NPDES stands for National Pollutant Discharge Elimination System. That's the surface water discharge permit that we would get for an outfall. One of the most important permits on this process. So we're developing a draft scope of work to present to the DEP and the EPA based on Massachusetts surface water quality standards and anti-degradation examples that we've been able to find from other Massachusetts and New England communities. DEP's implementation procedures for this anti-degradation evaluation define discharge to a high-quality water, like Nantucket Sound, as, quote, insignificant if it uses, quote, less than 10% of the unused loading capacity of a receiving water. It's actually pretty difficult to make that conclusion. The loading capacity is not established for all of the constituents, and it's a complex conversation. So we've been actually collecting some data to start on wastewater effluent and on Nantucket Sound to actually try to, over time, make this conversation a little simpler. And for nitrogen, where nitrogen is what's been the primary concern for the town as far as contaminants in the wastewater, there is not a nitrogen limit in the Sound that we could compare this to, but we have outlined for the regulators the way that we can look at that, which is we are going to be reducing nitrogen in Nantucket Sound by sewering, right? We're going to collect wastewater from all those septic systems along the shore, and we will then take that wastewater up to our wastewater treatment plant and use that tertiary treatment plant to remove 94% of the nutrients from that wastewater and then return it to an outfall. So we can calculate the nitrogen reduction to Nantucket Sound from sewering. We can calculate the nitrogen contribution to the Sound from the new outfall and demonstrate that we're not increasing the nitrogen, we're in fact reducing it. There's also narrative criteria, narrative description you get into about not impacting eelgrass and the habitat values along the coast. For other constituents where there are actual numeric criteria, we can do a little more straightforward analysis where we're sampling wastewater effluent, we're sampling the Sound, we use the model to calculate dilution, and then we compare the resulting concentration to the background concentration and the numeric criteria where it's available, and can make the conclusion about whether we're whether we're getting close to the 10% of the loading capacity. For some of these, there are additional narrative criteria that we'll need to address. In any case, this is an ongoing process, and we've made a lot of progress, and we really appreciate the regulatory agencies' participation with us in figuring out how we're going to do this. Public communication, we presented, Steve Rafferty went with me, and we presented and spoke with the Falmouth Heights Mara Vista Neighborhood Association at their annual meeting and the T-Ticket Association at their annual meeting this summer. Gave us a presentation to the Select Board last month, this meeting tonight, and then I've asked to do a presentation at the November town meeting to provide the town meeting with an update on this project. The schedule is not different from what we've been talking about in the past. We are.
Can you just back up one time?
Yep.
You and I have had a conversation that as we go forward, at some point we want to get ourselves out to the vineyard and let them know what we're doing, as well as in town, reach out to some other groups, whether that's the Chamber of Commerce or others. So that's not the definitive list. That's what we've done so far. We expect to be doing more over the next year.
Yes, and suggestions are welcome about who to talk with and how. The goal is to get the information out there and hear what people are interested in learning about it.
Sorry for interrupting.
No issue. So we're planning to conduct the marine borings this winter, complete the baseline data collection next summer, or next year, but primarily next summer. Submit an environmental notification form, which starts the environmental impact review process, the MEPA process, in 2025. We've left a long period here for applying for and receiving permits. We've already done the permitting for the marine borings. There are permits that we'll be requesting or applying for over the next several years. A draft environmental impact report, we plan to issue it by the end of 2025 or early 2026. A final environmental impact report and designing the outfall in 2028, and then constructing the outfall 2029 to 2032. Obviously, if we can do this faster, we will. This has been a big focus of ours over the last year, and we, as I said, we do have the regulatory agency's attention, so we want to take advantage of that and keep up the momentum, but there is a lot of work to do, so it's going to take quite a while, and this is our, we believe, realistic schedule for doing that. Just backing up the big picture on this is that the outfall is obviously a water quality improvement project. And I talked about this a little bit earlier, but this is something that it seems obvious, but we keep stressing with the regulators. While there's concern, there are a lot of questions about, obviously they want to make sure we're not degrading the Nantucket Sound environment. But you look at the big picture, and this figure on the right shows the green dots are septic systems. The pink area is existing sewerage area, so the green dots are existing septic systems. The ocean outfall will provide additional capacity to allow us to do sewering in these highly impacted coastal ponds, which means removing the septic leachate from all of these septic systems on the peninsulas within the sewer areas. So we would improve coastal pond water quality by reducing septic discharge to the pond. We'd avoid the impacts of treated water discharge to land, which I haven't spoken with you about tonight, but we've discussed over the years. This is how we ended up with this, with an outfall concept. And ultimately, we'd be decreasing the nitrogen discharge to Nantucket Sound from Falmouth properties. And that's it.
Thank you very much. Questions from the board? Jonathan?
So I'm interested in the USGS model, and you mentioned that they say preliminary conclusions, there's not a big impact on water quality, but what?
Water levels.
Okay, so it's the groundwater level and saltwater intrusion that they're concerned with, or subsidence from dropping water table levels?
I'm going to try this one.
Sure.
If I can. The Sagamore Lens is a body of water that sits like this. Mm-hmm. The concern has always been if you don't put that water that goes to a septic system back in the ground, but you put it in outfall, does that lens get smaller?
Right.
Okay? And the analysis that they did says almost insignificant, because John's going to help me here. There's a lot of water that comes down onto the aquifer, and there's a net outflow already going out. And so they looked at a lot of that, and they did these maps that look like what you saw, only they show like, it's over time, the shape of the aquifer will change by like 1/10 of a foot. But it's not going to keep decreasing 1/10 of a foot every year. There's a shift, but not a.
So it's a mass balance thing.
It's a mass balance. It's very much a mass balance process. Yep. They don't look at saltwater intrusion or those other things that much. It's because can you bring up that little. Good. So the thing to look at is that the lowest line on this map is 5 feet. The lens is 5 feet thick at that point, right? If you'll notice, everything on the south coast that we want to sewer is sort of past the point. It intersects the Coonamessett River and whatnot. So the fact that we're taken out from the peninsulas doesn't really affect what's going on up above. And John, Waterbury has articulated this several times, but we've now got people that do this for a living with a model and everything else. I'll say it, I mean, the one thing over the last year that is, I've said to a lot of people, if we're impacting the Sagamore lens, the outfall's not gonna happen. We met with everybody, and they showed us their results, but have not been peer-reviewed, and they go through an elaborate process. But after we had that conversation with them, I got up and did a little happy dance, because it was a better answer than I expected to hear.
And we did it sensitivity-wise up to the 4 million gallon per day level, the model?
We're sticking with the 2.
Why not run a 4, just because you mentioned that?
They did a couple of outlier things, but it's.
We also, we had them.
It didn't have that much of an impact at the 4, but that's so far out there, and the rules will change all over the place.
We also had them run a
2.
scenario where so we had them run 2, which is our proposed 2 million gallons per day, which is our proposed outfall. And then we had this, what if we sewer the entire town? What would that look like? To sort of bracket the,
They probably modeled 5.5, not 4.
Okay, so they've done the sensitivity.
yes.
Yeah. They did a couple different ways, yep.
I think the thing to keep in mind.
Go ahead, John.
Is that aquifer discharges to the coast in Falmouth approximately 40 million gallons a day. If you look at the Coonamessett River discharge in March, it's discharging 9 million gallons a day. So the impact of that outfall, according to USGS, will have a really negligible impact on the recharge characteristics of the aquifer itself. And the aquifer itself varies like mad. So if you look there, the head up in Sandwich, they normally says it has a head of 65 feet. But depending on the interannual variation, that can change by 10 feet.
Right.
Based on precipitation.
Yeah, right.
Yeah, drought and whatnot, yeah.
Changes several feet each year, just seasonally.
Goes up and down,
Yeah.
Yep.
Yeah.
Okay. Tom, you had your hand up.
Yeah, Amy, can you go to number 7? The signifying that using Nantucket Sound as the receiving water is the best possible case for Falmouth, right? Because Nantucket Sound is absolutely enormous, and if you remember, I brought up the point before, but actually the outfall's in Vineyard Sound. And I wonder if somebody somewhere along the line is going to say, well, actually, you're trying to cheat a little bit by spinning up the best possible, and how difficult would it be to model it using the Vineyard Sound data in addition to Nantucket Sound?
So I think, so we're calling it, you and I are talking about the same body of water, and we're calling it by different names.
Right.
We are disagreeing about the line between where Vineyard Sound stops
Right.
and where Nantucket Sound begins. So
And
it's the same place.
Right, because the U.S. Board of Geographic Names says Nantucket Sound starts at.
Amy's point is
this-
the name doesn't
Mashpee.
matter,
The-
because the
the-
nitrogen now goes to this mysterious place with an unknown name, and the outfall, it will go to the same mysterious place with a name that we can't agree on.
Right, but my point is I'm worried that somewhere along the line, someone will come along and say you're trying to cheat because you're making it look like.
You missed my point.
No.
It doesn't
I
matter
don't-
what the name is.
Yes, it does.
We're not, shh, one person at a time,
Yeah.
okay?
The evaluation has nothing to do with the receiving water. USGS is evaluating the impact on the aquifer.
I'm not talking about the aquifer. I'm talking about the
It's talking about
receiving water.
I'm going to try to answer this for you. Do you recall at the beginning, there was a slide about all of the coordination going on with the regulatory agencies? If there was somebody that this was going to be an issue for, I would say that we've talked about 40, 50 people, maybe more by now.
I'm not at all worried about those people. I'm worried about Joe Citizen, like the same people that get excited about other things, comes along and says, well, you're cheating here, and tries to gum up the works. That's all I'm
We're
saying.
not cheating.
So,
That's all I'm saying.
so we are so on this slide, when I refer to Nantucket Sound,
Right.
I'm referring to,
Show the sample station.
Right, but
I'm
that,
referring to this.
Right.
Like, we are sampling here, and here, and here, and here is where we're planning to discharge.
right.
Right? So whether you call it Nantucket Sound or Vineyard Sound, we are looking at a background where we're planning to discharge.
And that's where all the.
Right, yeah, I understand all of that, but if you're modeling the receiving water, it's obviously best case scenario for Falmouth to say, oh, we're discharging in Nantucket Sound where it's gonna have
Now,
less than.
so our
We're
modeler modeled
discharging at
discharge right here.
FOF1. We're discharging FOF1.
And you're modeling based
I know.
on the chemistry of FOF.
Yeah, we're gathering water quality data.
Right.
And showing that what we're gonna do doesn't degrade the water quality at that location.
Right,
Then the modeling was done for this location.
yeah, I don't
Not a
think it's gonna
location
have
for-
any effect. I'm just worried about somebody somewhere.
Somebody would want us to take a data point down in Woods Hole and use that?
No,
Well, where's the water quality data gonna come from?
I'm not talking about water quality data, I'm talking about the modeling. If you got a choice of dumping your waste in a small lake or a big lake, you'd like to tell people you're dumping it in a big lake because it's gonna have minimal impact, right, compared to the small lake.
The point is that the model of the physics of the water indicates within one model cell, 200 feet.
I know, I'm very familiar with all of those models.
You can't find what you've put in whatever water body we want to call this.
Yes. I'm not concerned about that, and I said, I know it's not gonna have an effect, but I'm just concerned that someone coming along is gonna be even more nitpicky than I am.
Impossible.
Wow, okay.
Good point.
Steve?
Yeah. On the baseline, you don't need to change the slides unless you want to, but the baseline survey for the eelgrass,
Yeah,
the reason for that
we'll change it.
is in case, for some other reason, not anything we're doing, the eelgrass gets worse in that area, we can show that it isn't because of what we're doing, because it's getting worse everywhere. It's some kind of
Correct.
red tide or
Correct,
something like that.
correct. Yep.
That's, yes, you want to know, it's basically a control. The outside
Right.
edges of this survey area are basically a control.
What I want to make sure of is the reason the regulators want that is so that if, God forbid, there was something that we did wrong, they could shut us down, which would not be a good day for Falmouth.
We will be required to do monitoring, and they will be watching, and we will all be watching that.
So have you, I want to make sure that someone that's good at statistics and biology has made sure that that baseline area is adequate to prove that it's not us.
Right, so it's a combination of the modeling, and we have Jim Churchill with Woods Hole Oceanographic Institution did the modeling, and then we have Scott Gallagher with who used to be with WHOI but now has his own company, Coastal Ocean Vision, and the two of them are looking at that very question and came up with the regulators with this survey area for that purpose. It's
And the regulators agree that it's sufficient for that.
Yes, it's called a before-after gradient survey, and they have the statistics summarized that they'll be using in that area.
Thank you.
Any questions?
Only a comment. Very thorough, remarkable progress.
Thank you.
Members of the audience, anybody have questions on where we're at, what we're doing, why we're doing it? Lauren?
Corin Peterson with the Buzzards Bay Coalition. I just wanted to echo Ken's sentiment. Congratulations to the committee. Great job, Amy. And the Buzzards Bay Coalition supports the work that the town is doing, and to the extent that we can help in any way, getting permits done, accelerating the time frame, we're here to help. So please call on us. Thank you.
Thank you for your support. Matt?
Matt Hanley. I'm a resident of Falmouth, but also on the board of Surfrider Foundation, Cape and Islands. Want to applaud this board and the Falmouth wastewater treatment facility for their improvements in their discharge. And obviously, this outfall would assist in the water quality improving on our south coast. Is it possible we can go back to slide 4, where that shows the lens? Now, all of us here have been following this for a long time, and we know how to look at the information that's being provided, but the people at home don't know how to interpret, what they're looking at here. Just from clarification for the people following this at home, the lens, this illustration is a little deceiving because it doesn't show the watersheds. And if you were to overlay the watersheds over this map, you would see the flow travels south, and then as it gets closer to the coast, it would take the path of least resistance and flow westward in Buzzards Bay, and then flow strictly southward in the South Coast estuaries and so on. And those red lines, are those delineating the rivers?
Yes.
Like the Coonamessett River?
Yes.
So Steve, would you agree that the direction of flow would be southwest or southeast depending on where, which part of Falmouth you're in?
Oh, yeah, yeah.
Okay. Yeah, and this is measuring the thickness of the lens, and that has nothing to...
It's not really measuring the thickness of the lens. It's measuring the height of the water table above sea level.
Right, but that's the lens
The lens can extend below sea level.
Okay, so this is showing how high the water table is above sea level.
Right.
And that has nothing to do with the topography of Falmouth.
It roughly parallels the
Because if you look at it, there's a lot, the west side of Falmouth tends to have more hills, but you don't really see that too much.
Yeah, it's not a detailed, and this is a pretty generalized set of contour lines, so
Yeah.
I'm sure, they have they have more detailed models around each of these water bodies that show even more refined contours.
But you see the rivers where the red lines intersect the lens. You see the lens drops where those rivers are
They're all
because
gaining streams, so the water flows, the groundwater is flowing into those streams, and as you move down gradient, towards the ocean, the flow increases because it's picking up groundwater.
so those rivers do have affected. It's the water's taking the path of least resistance and using those rivers as an avenue to the coast.
Yeah.
I just wanted some clarification for the people at home. That's important information so people understand the mechanisms and how it all works, because you can't see it.
Right.
And it's good to have experts like yourselves here that understand it, that can interpret it.
My actually only question on this diagram, Amy, and maybe is that the little blue area outlined, is that presumed to be area where there's fresh water underlying?
I don't even know. This is not a figure of our, this is not our modeling results.
Yeah.
This is just a figure that shows the groundwater lens in Falmouth, the Sagamore lens in Falmouth. So when we have the USGS report, we'll have a much more detailed map, not on, of the aquifer as it exists now, and then the aquifer showing the impact, the relatively small impact on the level in the aquifer based on the outfall discharge. So the small change in water level that is attributed to moving that water offshore.
The takeaway is that the outfall might make a difference of 1 inch in something that's varying plus or minus 10 feet from natural causes.
Something like that.
Yeah,
I don't want to say those specific numbers, but something like that.
And back to Matt's question about the direction of water flow, the general assumption is water flow is going to be at right angles to the contours.
That's what I was going to say.
Wherever, just if you draw little arrows across each of those contours at right angles at that point, that's basically the water flow direction.
Will the general public be able to get a copy of this report, the USGS?
In July. We will not have it until July.
July of next year?
Yeah,
Yeah.
it goes through a detailed review process inside the agency. It goes, reviewed by people, it has to go to Washington, and then it's got to be published, and then it gets released.
All right, so we will have access to it when it is released?
Yeah,
Absolutely.
Okay,
yeah,
all right.
there's several reports that are already posted someplace, they did a study of the Mara Vista Peninsula at one point. What was the, I can't remember the name of that one, but, yeah, there's different reports rattling around out there.
All right, thank you. I won't take any more time.
Okay. Anybody else wish to comment on this? All right, Amy, thank you so much.
Yeah. Good job.
Thank you.
And you know how that works, these get passed over and get posted, right?
Yes, this will be on the committee's website,
Okay,
along with all the other presentations.
all right. We're going to move to the next item, which is the suggested IA geoboundary for Oyster Pond. I want to do a very quick polling here because we do have to get out of here by 6:30, but our vaunted support person needs to be out a little bit after 6 if we can, because she's got another obligation that I don't want her to miss. So I don't want to shorten up the Oyster Pond presentation, so I'm going to suggest a little pond in the Falmouth Harbor, which we bumped already, will get bumped again, so that we have time for reports of members and staff, and maybe talk a little about where you guys are with subsidies and some of those other items, okay?
Okay.
And I just did that so you don't have to speak faster than anybody in the entire universe to get it all done.
So we're doing Oyster Pond tonight because we knew that there was going to be significant interest in it, so that's why we're jumping ahead. So we're going to get the spoiler alert of the final totals because we've been working east to west. So next week, just act surprised when you see the numbers, next meeting. So we're doing Oyster Pond the same way that we've done all of the other watersheds in Falmouth for consistency. We're looking at basically what it would take with tangible implementation where we can measure nitrogen reduction to meet our TMDLs. So the Oyster Pond watershed is a fairly small watershed, you can see outlined in blue. This watershed has roughly 190 parcels, 226 dwelling units. Of those, 149 are single-family residents. Since the Massachusetts Estuaries Project, the MEP report, the assessor's database has 13 parcels that are listed as year-built later than the MEP. The freshwater resource in this watershed is Mosquito Creek, and the MEP has it assigned a 30% attenuation rate. So for this watershed, there is a draft comprehensive wastewater management plan that was most recently updated in 2019. Through that CWMP process, the town selected 2 preferred options within that. Neither has been decided on, but in that draft plan, the 2 preferred options to meet the TMDL are either through the use of sewers or IAs primarily. So the data sources for this project are pretty much the same ones we've been looking at, the MEP, the TMDL, the Wright Pierce draft CWMP, SMAS data, and the Cape Cod Commission. So Oyster Pond has some unique challenges to it from the documents. So as I've been saying all along, the TMDL reports are primarily based on the MEP findings. In the instance of Oyster Pond, they do not agree. And what I was able to determine is that the TMDL is using a summary table from the MEP reports, and there's an error in that MEP report, which is inflating the TMDL for Oyster Pond. So in the MEP, if you use the numbers straight from there, the parts of the whole, you come up with a nitrogen reduction requirement of 1,076. The TMDL is using sums of the parts, and that's where the error is, and they're saying there's about 1,300 kilograms that need to be removed. So going through pretty fine detail, I would say it's pretty justifiable that the MEP numbers are more correct in this case. So that's what this is based off of. And then for added fun, because the Cape Cod Commission, the MVP tool has tended to be higher for most watersheds when there is a difference. For Oyster Pond, it's significantly lower. The Cape Cod Commission is saying that there is only 731 kilograms that need to be removed from this watershed. So, this is what the Cape Cod Commission has as far as where they think the loading is and reaching the threshold. The threshold from Cape Cod Commission is the same as the MEP, and the threshold is the same for the TMDL. It's just a difference in agreement of what the loading is. So looking at the MEP versus the MVP numbers, same as we've been doing, looking at the flow, the MVP flow is less than the MEP. So to add a conservative factor, we're using the lower water flow to determine the minimum amount of nitrogen that could be removed by implementing IAs performing at 10 milligrams per liter. So looking at the average single-family home in the watershed, an IA at 10 milligrams per liter would reduce about 3.5 kilograms a year. On sewer, it would be 5.1. For those homes that already have IAs, presumably performing at 19 milligrams per liter, the reduction is about 1.6 kilograms. So looking at the MEP nitrogen reduction requirement, along with the existing IAs, if you're looking at just single-family residents, you're looking at about 307 that would need to be upgraded to meet the TMDL. There are only 190 parcels in the watershed and 226 dwelling units. So, if you're following the TMDL numbers, that's saying 366 single-family residents would need to be upgraded. MEP numbers, because the nitrogen removal is lower, are considerably less. So here is the pond watch data for the Sentinel Station. And at the Sentinel Station, they sample a variety of depths, but the actual depth for the Sentinel Station is the 4 meters. So this is the data from there, the red line being the target threshold concentration. So you can see 2021 has some pretty high values and some pretty big variability. So if we just look a little bit, finer scale, this is kind of what the data looks like currently. So this proposed geoboundary, again, this does not mean that IAs have been chosen for this. There is a draft CWMP. The preferred options were either sewer or IAs. This exercise is just following what we have done for the rest of the watersheds in town. So to attempt to get to the TMDL using IAs, the entire watershed would need to upgrade. So within that district, there are the 190 parcels. We've also been doing the IA lot screening size, so identifying lots that may not quite have enough open space available to easily install a denitrification system. So lots where it may be additional engineering challenges to install an IA. So this is just the map of that. So if we look at with water use, looking at the average nitrogen reduction, considering the attenuation potential in Mosquito Creek, if you upgrade all of the IAs within the watershed, coming out with a minimum of 608 kilograms of nitrogen to be reduced when you need 1,071 after the existing IAs. This is just the MVP data, which also shows that you don't quite get there. So, comparing it to what is present in the existing draft CWMP. And again, it's a draft CWMP. It has not been submitted nor approved by any regulatory agency. The way Wright Pierce looked at it was more from the actual loading as opposed to the reduction. So once they removed, they calculated the remaining load. So they broke it out into the different areas. They also, for the IA option, recommended upgrading every developed parcel in the watershed to an IA performing at 10 milligrams per liter. The difference is they take into account all of the other credits, the theoretical credits, the lawn fertilizer, 25% reduction, stormwater. They take a 25% reduction for natural surfaces, which I've never seen any other town look at that as far as a reduction. But Wright Pierce also incorporates a 40% reduction in atmospheric deposition. Again, I've never seen other towns take that into consideration when calculating the actual load reduction. But that is how the draft CWMP is getting there. Again, IA upgrades in every parcel in that watershed. So, without looking at the potentially non-measurable nitrogen load reduction, so your fertilizer and your stormwater, just by upgrading alone will not meet the TMDL. When you look at fertilizers and stormwaters, there's, a small fraction to be added. There's no shellfish proposed for Oyster Pond. The proposed IEA district represents 100% of the parcels in the watershed. So, looking at the map, again, we haven't talked about these two, but this is what the full map for all of the geo-boundaries we've discussed for town, and the two we haven't discussed yet, looks like. And then the final tally table. So we're looking at 7,638 within those IA districts across the town.
I just want to understand, like, one of your fundamental numbers, if I can. You say there's 190 parcels.
Yep.
You say there are 149 single-family residences. Treetops is one parcel?
Yes.
So when you talk about 226 dwelling units, you've added in dwelling units for treetop or not?
The treetop dwelling units are included in there. That's the number that Wright Pierce was using for their determination.
I thought that's what was going on. I mean, there's no other large parcel that's got multiple.
So in the Wright Pierce CWMP, the Hui dorms are included in there.
Okay.
But in the Cape Cod Commission, so when I'm doing all of my numbers, I'm relying on the designation from the Cape Cod Commission of where a parcel is.
Yeah.
So, and they say that parcel's not in Oyster Pond, and that's to prevent duplication maybe between watersheds where you actually have two impaired areas on a borderline. So, whether it's in this watershed or not, it really depends realistically where the leach field is and its contributions.
Yeah.
But for this exercise, it was not included in here.
That's fine.
Are you going to say something about what it would be if sewers were used?
Nope, I haven't done with any other presentation, so no.
Yeah. But that's obviously an option.
Sewers remove more nitrogen than an advanced system, yes.
I need to know more about the process, which you may not want to do now, but.
At some point, we're going to have to make a watershed plan for each one of these estuaries. When that plan gets put together, it will look at, things like permeable reactive barriers, possible sewering, et cetera. They'll have other factors in there. We've just been marching through each estuary saying, if all we've got in front of us is advanced treatment and the existing areas defined for sewers per approved watershed plan, what do they, I always forget it, what's the plan called for the South Coast?
The CWMP.
TWMP.
C.
Yeah.
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 And it gets complicated here because there's some talk of moving the force main that's now under the bike trail
Yeah.
up to Oyster Pond Road and Woods Hole Road,
Right.
in which case it would be going right by,
Yeah.
which would,
Yeah. Every one of these estuaries has some, Bourne's Pond inlet widening is a factor in one estuary, it's different for each one. I'm going to start at the far end.
So, Kristen, in all of these, you've been using conservatively, right, the regulatory, presumed regulatory limit on the IAs?
Yes.
Which is,
10.
are you assuming 10 milligrams?
10.
And we know some of them have a median performance better than that.
Yes.
So I'm just wondering if that's something that should be addressed at all, because, the last time I checked the Mass TC site, for example, for the nitro, median was 4.57.
So throughout all of the discussions, when you talk to people who have been in this for a long time, like George Hoyfelder, when discussing with the state what kind of credit you'd receive for IAs, they're really only going to give you the credit to the approved performance level. That has not changed yet. Whether they start accepting the actual monitoring data to give credit for that. So we're looking at if a system is approved for 10 milligrams per liter, that's the expectation that it's going to make that hopefully better.
Right, and the 10 milligrams per liter standard is not yet official, is it?
Correct.
So what's the process for getting that to be official?
So right now, the watershed permit and the Title V stuff talks about, the target is to get to 10, okay? I mean, they're very clear in there about that. Right now, we have one system that is on the verge of having 50 installations in 3 years of data, and then it gets approved, and then there's now an approved system at 10 by the DEP. That's the process.
So once that system submits their data, DEP will say, okay, this, we can approve something, we can set a standard at 10 because we have a system that performs that well.
I'm not going to speak for the DEP as to what they will or won't do, but that is how I understand it. For example, right now, there are systems that are approved for 19.
Yeah.
Okay? Some of those perform at 25 or 30. Some of them perform at 11. But, you know, nobody's going in there and, you know, managing those numbers. I would suggest, though, that since once we have a watershed plans in place and approved by the state, which will include some extent of areas that need IAs with some anticipated value, there's every 5 years you need to provide monitoring data, explain where you're at, and I would say, you know, once some of these things get in place, if the performance is better and you can say, we only need to put in X instead of Y because we've got now, you know, 1,500 of these installed.
Right.
And you look at the, but if you go to the Barnstable County's data set right now for IAs, you would say that getting a system that performs at 19 is unusual, okay?
So those are for general use systems. The two systems that are being talked about are under provisional approval, so you can install those, and one is provisionally approved for 11 and the other is provisionally approved for 10. It just means that there's increased monitoring requirements for a much longer duration until it's general use approval. So it doesn't limit you to not using those systems. DEP, it's on their list. They're just not general use approval.
Right. And the part that I'm still fuzzy on, though, is now if we're going to mandate, we're doing that, the town is doing that, the Board of Health is doing that, or DEP is doing it?
DEP is not going to say, they've left it up to the towns to do watershed plans and submit them. And that plan has to show how you're going to get to the water quality that you need to get to.
And then is that the Board of Health that's purview, or is there some broader bylaw or something that gets written?
So I'm going to ask you to hold out those thoughts, because what we've been doing is a march through of, like, you know, the scale of this. Then we've got a meeting or two where we're going to talk about what I like to call the conditions. And then we advise the Board of Selectmen.
Right.
So once we advise the Board of Selectmen as to where we're at and things that need to be done, which is why we're communicating, some decision we made, not by this board, about whether it's going to be Board of Health fiat, which they possibly could do, or whether it's going to go to town meeting for, you know, I guess it's like one of those ballot questions where you're like, how do you feel about this? I don't know. But yeah, that's to be worked out, Ken.
Okay, good. I have a better understanding. Thank you for clarifying.
Right. You're up.
Ken really hit the topic I wanted to mention, is that there are systems now performing better than 10. Now, I think the question's going to become, at what level will the nitro, which is showing better than 5, going to be approved for general use? And I don't know the answer to that, but it might be worth asking Nitro and DEP. If Nitro gives you data from the 50 for 3 years and it shows better than 5, will you approve them at a 5 level, and that becomes the new goal? And there are a number of groups working with Nitro and other companies that are performing at those levels. They're calling them EIAs, Enhanced Innovative Alternative Systems. So at what level will it be approved? If it's at 5, we've got a shot at getting to the TMDL goal. Otherwise, for Oyster Pond, you can't get there.
Right.
We do not have the ability to meet the TMDL, and it's kind of like uh-oh, what are we going to do for that watershed? And realistically, that's probably the only way to get there unless you said sewers.
Yeah.
And that's not even in the horizon plan. And, you know, we're talking 20, 30-plus year plans for some of this sewering, and you know, where the money's going to come from and how and when and the logistics and all of that isn't in the planning right now. So that's the only way to get there. But I don't think we know anyone, unless somebody corrects me, that what they're going to approve that general use level at.
So take a step back here, okay? Keep in mind that back several months ago, people were saying, oh, Mashpee says if you're within 1,000 feet of a water body, you have to do something. People were doing these distances from water bodies sort of criteria. What we've been doing here is, does that, you know, what's the real thing? Inside a given watershed, using 10, which is the target they've got, could be better, but using the 10, because it at least looks like there's a shot at getting units that at least operate at 10, maybe a little lower, but at 10. How many properties would have to go to an IA system? You know, like, and we're seeing for some of these estuaries, even that doesn't get there.
That's right.
Okay, so this exercise is leading us to the scale of what's out there. How big is it going to be? You know, we're not talking that we're putting in 50 or 100. We're talking putting in thousands of these. But the actual delineation of some of this stuff will come out of the watershed plans. This whole thing is to identify the scale of what's in front of it.
Yeah.
What you know, we could say, oh, you know, people are wealthy if they live on the water. Tell them to put in an IA system, but it might do nothing. You know, we want to identify the scale of what we got to do, and I think we've done a good job of getting there. We haven't tried to take into account oysters or fertilizer. We've kind of left all those soft things off the scale a little bit. But when we come back to doing specific plans for specific estuaries, which is going to take a lot more work than Kristen's been doing here, you know, there'll be a specific thing. You know, in this estuary, we're looking for a fertilizer reduction of X or Y through whatever mechanism. Different things. Over here, we're going to want to put in a permeable reactive barrier at this location and that location because it'll cut off and have some value. So this is really the high elevation. And show us that map that shows a lot of the town is now blue, right? I mean, 4 months ago or 5 months ago when we started this, I don't think anybody sitting here on this board, at least not me, thought that the map was going to look like that. I thought there were going to be smaller maps running up the water bodies. But they're not. It's not. That's what we're looking at. You know.
Remembering that we started the exercise on the IAs because the DEP said if you don't do watershed plans in X number of years, you will put IAs in every home in the watershed.
So this is showing you how much fewer IAs you have to put in rather than every
Right.
home in the watershed.
And that's why we're keeping a running total of, you know, we're looking at less than 50%. But the DEP has said, if you don't do it, baby, you're going to do them all, and within 5 years.
I'm going to pop down here because I want to get her out of here in the next 5
done.
minutes. We're happy? Good?
Yeah, I don't understand some of those credits that were listed there, you know, for hard surfaces and nitrogen in the atmosphere, but that seems kind of fuzzy at this point to me.
Right, it is.
I turn you loose to give Kristen a call one day, and she'll walk you through it.
Yep.
Okay? Any questions from the audience? I'm going to go to Miss Lowell.
There's two Miss Lowells.
That's right.
Yes.
Yeah.
Hi, Vicki Lowell. I live in Treetops, and I'm wondering if the time comes, which seems like at least a decade away, would you say? I don't know, but that we'd actually be doing putting anything into the ground. But we have now, I don't know how many, but there's, 15 buildings, and there's usually maybe 2 septic systems for each building, so, let's say, I'll just guess we have 30 septic systems for the 62 units that we've got. Is there thinking at some point that that we could get more nitrogen out if you made us do maybe treetops, not us, a package plant?
Yes.
Rather than having to do denitrifying, IAs. IAs, maybe it'd all be run by AI, but IAs, or is that too far down the road to know what direction you'd be leaning in that way?
Yeah, I'm not gonna try to project, again, once we get plans in place and each watershed gets told what they're expected to do, it would be up to treetops. They might come in and say, we hired an engineer, here's how we're gonna get to that.
Oh, okay, it might be like, well, because treetops just not unique to the town, there are other
Understood.
developments like that, so.
It's a possibility, and in fact, Richard Hale, who you probably know of,
Yeah.
spoke to John Smith of Nitro E 8 or more years ago about possibility of a package plant.
Yeah.
Definitely not ruled out.
So just to give you a frame of reference, there's a 32-unit subdivision off of Brick Hill Road right now. You drive by, you see the houses stacked one on top of another. They have 2 IA systems in there.
Yeah, I'm just, so there'll be, it could come to the treetops itself deciding how to if they were assigned a certain amount of loading that they can have, they could decide whether to have 2 package treatment plants or 1 or none, or,
What we have learned is that if you tie a number of homes together,
Yeah.
you get more reliable performance. And number 2, you have to sample one system 4 times a year, and not 32 systems.
I've thought about this for a long time, so, and I have a little input locally too. Thank you.
I don't know you, so you'll have to identify yourself. No, not you.
You know me.
Next
Okay.
person. Yep.
I thought you were still speaking to me. Thank you.
Really nice to see you.
Hi, this is Meredith Golden. I'm also from Treetops, but my question is a broader question. With the AIs, we're focusing on reduction of nitrogen, I believe, but with the sewer system, we can also treat emerging chemicals of concern, which of course are prevalent around the Cape. So what consideration will go into the degree to which we depend on AIs but not address these other chemicals of concern versus a sewer system that might be able to, over time, identify and then focus on those as well?
I'm not going to speculate right now on that question. I'm sure that there's data out there about how septic systems or IA systems perform. I believe various people are looking at, to what extent they break things down inside their biology. Okay, so I don't have that in front of me, so I can't.
Well, I guess my question is, I hope that the committee will contact the experts, and some of them I've heard from, to address that issue, because over time it's going to cost the town a lot of money to go one direction and then realize, oops, we really needed a system that would address all these problems. So thank you, and I appreciate all the work you're doing.
All right. Be brief, Matt.
Yeah, I'll keep
Okay.
it short.
It's okay.
I don't want to keep Kristen. I've been attending all these meetings, Matt Hanley from Thomas Landis Road, Surfrider Foundation. But I've been attending all these meetings, and, we're talking about total nitrogen being removed, but it seems like we're focusing on the single-family residences and not calculating, like, other factors, like hotels, businesses, schools, administration buildings.
You brought this up at the last thing, and that one of the reasons I, at the start of this, went back through the numbers with Kristen a little bit is, again, this is the bigger picture right now. When we get into watershed plans, you're in your Mgmt, you got to look at the Royal Mgmt.
Right, exactly.
So, again, this is the big picture.
But the problem is, by starting off focusing and judging every parcel the same. Instead of saying, these are our major contributing factors, we should address these.
I'm going to try this one more time with you.
Can I?
This is
Yeah.
the broad picture.
Yeah.
We're gonna retain consultants to write watershed plans. We're gonna drill down to what are the real uses inside this watershed? Who in that watershed is contributing, a bigger nitrogen load? And then how big is the geoboundary at the end of the day? They will shrink as we look harder at things like hotels and nursing homes and things.
So these are maximum numbers for each watershed?
This is showing the potential worst-case scale scenario based upon the 10 milligrams per liter single-family residence.
I'm just trying to speak for all the residents of Falmouth, and we want to address the major contributing factors before we start going to the residents and putting the burden on our homeowners. Okay, thank you.
All right.
Can I follow up? So in these geo-boundaries, any parcel that's highlighted for the single-family residence, I'm taking the average water use for all of the single-family residents within that watershed. If it's anything other than that, I'm using the actual water from that parcel calculated in there. So that's covering your schools, your nursing homes, your multifamily parcels. They just get treated a little bit differently as far as how I can back that back into the way the MEP did it. So I am accounting for the nitrogen potential, reduction potential from those parcels. And when I'm looking at this, what I'm looking at is where I can, areas where the travel time for the groundwater is less than 10 years. So that if you're putting these systems in, you have a chance to see that impact sooner rather than up here where it could be 50 years until you're seeing an impact. That watershed doesn't make the TMDL, that's why the whole one is there. So those are being taken into consideration. So it's not just single-family homes in this.
Well, I appreciate that. That's the answer I was looking for.
Yep.
Thank you.
Thank you. You can check the tape for
Okay.
committee members' updates. Reports of members and staff. That's fine. No, that's fine. Ken, you touched upon the Little Pond stuff you were doing, but I don't know that we ever got a presentation on that.
No, I mean, I
Can we
have
put
it
that on
if you have time.
We want to put that on another agenda. Do you have Ken lined up?
It's on there. It's on the left-hand side.
It would be pertinent to everything else that was discussed,
Yeah, so
if you want.
Do you want it up?
Sure. If Steve wants me to.
Second from the bottom.
yeah, let's do, while you're queuing that up, I'd like to jump to item 7. Can I have a motion to jump to item 7, minutes of prior meeting?
So moved.
Okay, second. All those in favor? All right, we're going to go to item 7. We have the minutes of the prior meeting. Everybody's had them, distributed them, read them. Has anybody got any comments on the minutes?
I move they be accepted as written.
Second.
Okay, moved and seconded. All those in favor of accepting the minutes as written?
Aye.
All right. Ken, you're on.
Okay, so as you guys know, I've been working on the Little Pond system and with a general question of, okay, here's one that we actually have built sewers around, and how is it responding to that reduction in nutrient inputs? And some of that information is relevant to this question that's popped up about the exchange with Vineyard Sound and, to the whole Bournes Pond inlet widening. So here's our system. We have our inputs from both direct precipitation, stream flow, and groundwater. And then as we have removed the nutrient sources, we expect a decline in groundwater, but we still expect some time for recovery to occur because we're going to get benthic nitrogen regeneration. And then we're also monitoring what's the response to the ecosystem, how is productivity changing, oxygen dynamics, and there is also, of course, nitrogen uptake associated with the growth of all these critters in there. And finally, the fundamental process that will clean up these sediments, which is denitrification, removing the nitrogen, converting it to nitrate, and then to N2 gas. So all of those processes kind of get integrated into this nutrient exchange, and that's really where we're focused, looking at what's going in and what's going out. And that's where the relevance to the whole issue of exchange with Vineyard Sound comes in. So just a couple of, some of you have seen some of this before, but the first thing we did starting back in 2015-16 was put in a set network of monitoring wells around the pond, and each of these wells has somewhere between 3 and 5 depths that we sample. And what you can see in this first panel here is that, you know, in 2016 at this LP1 site, we had very high nutrient levels in the groundwater, and they dropped consistently every year after the sewering was implemented. So 2017 in the blue, 18 in green, and so forth, and now we're down somewhere maybe a third of what the initial levels were, and we can see similar patterns at other wells locations, even though each one of these wells has sort of a unique set of profiles. So, you know, up here at LP1, they're all vertical profiles. We don't see any subsurface plumes, whereas at LP4, there's a deep plume. Probably we're capturing some plume of nitrate coming from a septic system further up gradient. When we take all of that data and summarize it over the period of time since the sewering was implemented, back in 2016, all the homes were pretty much hooked up, and it took maybe another couple of years for the effects to kind of manifest. We see this general decline, and this is data up through spring of 2024. So general decline in the levels of nitrate in the groundwater. The offset is actually, there's a few of these wells that have some ammonia inputs, and most of those are actually associated with saline groundwater, so not so much fresh water. But that's sort of, you know, the time course that we might expect to see replicated in other systems where we remediate. I mean, all of these ponds are very similar in their morphology and geology. So then the question of the inlet. So here's the, you know, Little Pond Channel and the other sites that have been already mentioned this during the meeting here. You know, this Center for Coastal Studies system further out in Vineyard Sound, SMAST site off of Green Pond, I guess it is. We have been collecting as frequently as we can water from the inlet over multiple tidal cycles using an automated sampler. So we collect a sample once an hour, collect actually 2 samples once an hour over 4 tidal cycles over 48 hours. And that's the data I wanted to show you to talk about this exchange issue. So what you can see in this figure, first of all, we're monitoring flow. We have an acoustic Doppler system to measure flow rates. We also have pond level monitoring. The two agree pretty well. The amount of water that we see, you know, expect to have moving through the channel based on the volume change in the pond matches what we see in the acoustic Doppler measurements. So we can look at how much water flows out, and then what you can see here in the pink-coated areas, that's all flood tides, or that's ebb tides, and the blue is the flood tide period. And so, you know, we have higher chlorophyll levels coming in this particular set of data, or leaving rather, on every single ebb tide. We have higher total nitrogen going out on every single ebb tide, higher carbon, milligrams per liter, and actually the pond imports a little bit of phosphorus. And so we can then estimate the net exchange by simply taking our flow rates, multiplying it by our concentrations, summing it up over the multiple tidal cycles for each constituent to get a net flux. And when we do that, in these examples, we're seeing, in this case, we're trying to get as close to break even as we can in the water flow, so we're ending the summation at about 46 hours, where the pond is just slightly increased in volume by about 925 cubic meters. Even though there's a little bit more water in that pond, we've exported 0.33 kilograms of chlorophyll, 16.6 kilograms of nitrogen, 73 kilograms of particulate carbon, and we've imported a little over a kilogram of phosphorus. If we look at the ebb versus the flood, for, in this case, 96 of these samples, you can see that our numbers actually are very similar to the ones that I think John Ramsey mentioned. The ebb flow is putting out about a mean of or median, I think this is, of about 0.3 milligrams per liter. The flood is bringing in about 0.24. So, but I think that's about a 40% difference between the ebb and the flood. But it definitely shows that Vineyard Sound water is a lot cleaner. And this is after sewering. So this is, you know, our ebb tide waters would have been probably much more enriched prior to sewering. There's the data from this NTKS 10 site that you showed earlier, Steve. Further out, and we're getting 0.15. I think John said 0.16 as the mean value there. So again, consistent with everything else that's been shown. So I guess the conclusions pertinent to the issue of exchange, nitrate levels in the groundwater since the sewering have decreased by about 2/3. Concentrations in the flooding waters from Vineyard Sound are about 0.3 milligrams per liter compared to data from stations further offshore of about 0.15. Our ebb tide waters have a mean concentration of about 38% lower, or higher rather, than the flood tide waters, and that was in August of 2023. And I mentioned already the export numbers. And so I think all of this is consistent with all the stuff that was shown earlier. A little more of a deep dive into one performance in one particular pond.
Thank you.
Can I,
Sure.
that was great, Ken, thank you.
Yeah,
Got two
very good.
questions. One is there any way to, I mean, I assume we're now waiting for the benthic stuff to happen
Right.
before the Sentinel station changes.
Well, you know, House mentioned that he thought unless we widen the inlet, we're never going to see dramatic changes further up in the pond. There's a pretty big difference between the north and south ends, and I think John mentioned the same thing. There's sort of a natural, because of the length of the residence time, tendency for those to become more enriched. We've been hovering around 0.4 something, but a little over the 0.45 limit at that site. So we've been doing surface surveys similar to what, you know, that.
But you've shown that there's less coming in and that there's some going out,
Yeah.
which may have always been going out.
Right.
So things should be getting better.
Well, I don't know if I add up everything, so we haven't gotten yet
Thank you for attending.
we haven't gotten yet to the point where we can add up all of the export and compare it to all of the stuff, all of the material coming in over an annual cycle, right? We need to.
Let alone the mass on the bottom that you have to get rid of.
Right, but in general, I think these systems export less than they get because of denitrification.
And the last question is, where does the phosphorus go?
I assume it's taken up by the plants
And then washed out as plants?
maybe.
Well, I mean, if it's been coming in for the last 10 million years.
Yeah.
There's a lot of phosphorus.
Yeah, so there's accumulation. But this is not an uncommon pattern to see some phosphorus import. You're adding all this nitrogen, so to balance that, you might need to get some phosphorus from somewhere.
But the
And we-
phosphorus has to leave, too.
Well, right, but it's being retained because it's needed in there to support the
For a
growth.
while.
To support the productivity of the organisms, the plants, producers. Does that make sense?
Tom? John? Tom?
I think this is great. This is really nice stuff. I like the mass balancing, the black boxing and stuff, and I'm encouraging Ken to keep at it.
Jonathan?
Ken, what you might anticipate is that little average of the ebb, where you had the pink, if you do that from year to year,
Right.
you would anticipate that it ought to gradually decrease.
I wish we could have
Yes.
studied it in this detail starting back in 2016 and had a totally parallel data set with the groundwater. That would have been a phenomenal study. But it's
But you could do
expensive,
that going
expensive to
forward.
do the work. But that, of course, is our objective, exactly. And also, when we look at, so we also have signs out there measuring total productivity. We have some of Matt Long's equipment from Hui, also measuring productivity and oxygen dynamics. And so, we're expecting to see changes in the daily excursion, in oxygen, less hypoxic and anoxic events. I've gone out there, there's 200% supersaturation in the middle of summer. There's so much productivity, but then you get a couple cloudy days and you have a hypoxic event. I would think over time we'd see that basically tail off into a narrower range. So, John
Just
had
had one question. It looked like in the last 3 or 4 years for the nitrogen, it was starting to level off, and it was
think so.
almost flat.
Yeah.
Do you think that's
I think
just a blip statistically, and ultimately the long-term trend should be to drive it down further?
So I didn't show this slide, but if I make certain assumptions, I can take the decline in groundwater inputs and convert that into a actual loading estimate. And as I understand it, the plan was to remove about 5,000 kilograms in loading, and we're at about 4,500 kilograms reduction in loading. So I think, based on the amount of sewering that's been done, we're pretty close to, the end on what we might see for improvements. It may drift a little bit, down further over time, but if all happened a lot quicker than I anticipated. But Steve mentioned that USGS did a survey. That survey on the Mara Vista Peninsula predicted about a 2-year lag.
Mm-hmm. Yeah.
And that's kind of what we saw.
Yep, pretty much.
So I'm always amazed when things agree.
When the model turns out dead.
The model worked, heaven forbid. I would say this, and not to prolong it, but, the dynamics of the Little Pond neighborhood are extremely unique. It's just probably one of the most thorough studies that's been done on sewering effect of an extremely densely populated area. The housing has changed dramatically since the sewering.
Yes.
More converted to
Year-round.
mini mansions, year-round occupancy, and the sewer takes care of the human discharge. But man, there's some real big lawns that are heavily fertilized.
There are some pretty green lawns out there.
There's some pretty good.
Yes,
the
that
other
weren't
thing-
there 10 years ago.
The other thing that I've noticed, and a couple of the residents have commented on as well, is when they get a big rainfall event, there's a lot of runoff. And we've seen it in the pond level. I mean, the inlet is so constricted that if there's a large rainfall event, we might see, half a meter increase in the pond level from fresh water accumulating in there. And that also a lot of sediment and other stuff.
Very
that's
large stormwater retention basin.
delivered in there, right? So that, if that, I thought that might be one area where if something, useful was going to come out of this, that we might think more about some kind of stormwater management for the pond system to accommodate that, because there's, a lot of little roads that end right at the edge of the pond.
But if the volume is half a meter times the area of the pond, that's one heck of a big retention thing.
Yeah, well, remember, it's not the area of the pond, it's the area of the watershed that's draining into the pond.
But Steve just said that, or somebody just said that the level of the pond sometimes goes up half a meter.
I've seen it increase by that amount, and then over a period
So
of days, it drains out, but you're collecting from a much larger area, right?
Right. No, I'm not saying it doesn't happen. I'm saying that since it does happen, anyone who proposes a retention system to stop it from happening.
Oh, yeah, that would have to be.
Has to find an alternate location that has one heck of a big volume.
Yeah.
All right. Last item of business, there's no debate on this motion?
I move we adjourn.
Second.
Yes.
Okay. Thank you, Ken, that was good.